for the coding session. Here I'm using the Spider IDE, Spider Integrated Development Environment, which is available in Anaconda environment. You can install the Anaconda environment and use this Spider IDE. So in the Python course folder, I make a subfolder k-means, and in this subfolder I make this k-means.py Python file, and I make this k-means.py Python file, and in this Python file we are going to do our coding session. So first of all, let me import some of the basic libraries, and now in the sklearn.dataset import make blobs. Make blobs is a functions which is used to make some make some clusters. Like here I specify n samples is equal to 300, like it makes 300 samples points, and having 5 center means the five clusters, and the standard deviation is cluster standard deviation is about 6. So let me execute this so that you can see what is happening. So I'm going to plot this, and you can see I just make 5 1 2 3 4 5 5 centers, and this is on the random basis. So we have to iteratively do, and we have to stop at that point where we get some beautiful 5 clusters where we can see them independent, where we can say that the algorithm can differentiate between these 5 clusters. So I think these 5 clusters are fine, or let me try some other clusters. And yes, I get the 5 clusters. As you can see, these 5 clusters are easily identifiable, and now I will pass this data to the algorithm and see that how our algorithm shows that how many number of clusters should we have to take, or the what is the number of proposals it will tell us that the number of clusters should we make. So first of all, I import the k-means class from the cluster module in sklearn library. And now I make a WCV variations, and the variations within cluster variations. Now I am do this in a iterative format, like I k means sorry, in k-means class I specify n clusters as I, and from the range from 1 to 16 it makes clusters, and it makes a beautiful graph for us, and I just append the inertia of them. So yes, so let me plot this WCSV list which I append, which I get. So as you can see, I append these WCSV within cluster variations, and I plot this graph where you can see these are the number of clusters: 16 clusters, 1 2 3 4 5 till 16. And as you can see from this graph, let me make it more bigger, and you can see that we have four elbows: one, two, three, four cut points. And according to this graph, we can select any clusters. Like we can make 2 clusters, we can make 3 clusters, we can make 4 clusters, or we can make 5 clusters from these points. And it will depend upon you that how many number of clusters you want. So like I am making the from this graph, I say that I make 5 clusters. And when I say that n equals to 5 in k means and predict them, and I plot the cluster for that, scatter that, then I can see that it will easily predict that these are the 5 clusters. And the let me plot this again, and you can see that 4 is also correct, 3 is also correct, 2 is also correct. This is unsupervised learning. Here nothing is wrong and nothing is right. We have to choose the things according to our convenience. So we have seen that 5 is convenient to us, so let's try the 3 and 4, that how it's look like when we say that we have to make 3 clusters. So for 3, I just comment these two, and let me show this. So you can see that we get 3 clusters. And wait a minute. Yes. So If we want four clusters, then specify 4 km wide, and now let me plot the four clusters for them for you. And you can see from the five blobs we get the four clusters. One is top, second, third, fourth, and I think I make a mistake while making three clusters. Yeah, this is our we make three clusters from the five clusters. It takes the top two, then it take the middle one, then it take the bottom two. So that's how it make three clusters from these five clusters. And let's make two clusters, because it is also saying that two is also good. So it make two clusters on the basis of these negative, the points which came under the points which are equals to 0 or less than that, or the points which are positive. So you can also mm, do you can it's all depend upon you, that by seeing this ws wcv plot within variation, within cluster variations, what is convenient to you. So all we know that we make five clusters and we are convenient to five, so we work with five. But it all depends on you, that how many clusters you want to make. So we know that we make five clusters, and for us, the five is the correct answer. And as you can see, the algorithm is also says that we have to make five clusters, and when we make five clusters, it is making a beautiful five clusters. So that's all for this today's session of k-means cluster. And I just want you that I just want to say that you just do more and more practice on that, so that it will get so that your mind will clear about the basics of these k-means clustering. And that's all for the today's session. Thank you. Bye. Take care. Stay motivated and keep learning.